notice, and this is the typical copyright. We continue with mathematics syllabus 2018. Note that as of January 2026, this syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and moving forward. But right now, there are a few pilot projects being conducted in a few Caribbean countries. The contents of the syllabus itself remain unchanged. The two main planned changes to the CSEC level math exam are: one, split the exam into two parts, and two, there will no longer be any alternative sections. All sections will be tested using compulsory questions. Schedule of videos, as you are well aware by now, these first three sections, all 51 of those videos have been published on YouTube in their entirety. Please make good use of them. From sections 4, 5, and 6, some of these videos have been published on YouTube in their entirety, the others only partially. We are now at section 7, relations, functions, and graphs. This is the 23rd of 26 videos. After that, of course, we still have geometry and trigonometry to do, section 8, and then section 9, vectors and matrices. Hopefully by April, May 2026, that will be completed. Please note this disclaimer down here. This schedule is just a projection and it is not to be interpreted as a contract with anybody. Just a reminder that section 1, number theory and computation, I have divided that into 33 videos and they are all published on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. Another reminder, you need to know the times tables from 2 to 12, especially since calculators are not allowed in paper 1. Back to section 1, some of these videos are even applicable in the primary schools, where students can use them individually. Teachers can use them as in the inverted classroom, and parents can use them to refresh their memories about work that they did so many years ago so that they could help their children in primary school. Remember that this is section 1 of the CSEC syllabus. If you consider this box here, let's expand it. You will notice that video 6 says add, subtract, multiply, and divide whole numbers, which is work done in primary school from grades 2 and as grade 3 and more so grades 4, 5, and 6. And then you have add, subtract, multiply, and divide decimals in video 7, and in video 8, add and subtract fractions, and then video 9, multiply and divide fractions. So even in the primary school, especially grades 4, 5, and 6, these videos from section 1 of the syllabus can be effectively used. From section 2, consumer arithmetic, all 12 of these videos have been published on YouTube in their entirety. From section 3, sets, all 6 of these videos have been published on YouTube in their entirety. Section 4, measurement, as you can see, these indicated in yellow here have been published on YouTube in their entirety. The others are only partially published. If you need full access to these videos that are only partially published on YouTube, please see directions in the description below. Section 5, statistics, same system applies. These have been published on YouTube in their entirety, and these others only partially published on YouTube. Again, if you need full access to these videos that are only partially published on YouTube, please see directions in the description below. Section 6, Algebra. 7 of these videos have been published on YouTube in their entirety, especially since many learners find much difficulty with algebra. And then, of course, the others have been published partially on YouTube. Again, if you need full access to these videos that are only partially published on YouTube, please see directions in the description below. We are now at section 7, Relations, Functions, and Graphs. This section has 26 videos. We are almost to the end. Before we go on, recall I said in the introductory video that you will need a good math textbook or maybe a set of two, especially to get more practice questions. CSEC recommends the following, shown at right, these here. From those, I would recommend these last two down here, as seen on the next slide. Volume 1, Mathematics, a Complete Course with CXC Questions by Raymond Tulsi. And then, of course, Volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, as of late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, specifically from paper 2. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. The URL for that math website is this. And on the next slide, I will show you what the home page looks like for that website. This is the home page. You will have to register and subsequent to that sign in, but as I said, it is free. This is the URL of that website again. It will be included in the description of this video below, so you can easily click on it and be redirected to this website. Another reminder that this formula sheet that you see on the left here will be provided for CSEC math examination papers. This formula sheet is also included in the syllabus if you have a full copy of the syllabus. If you don't, there will be a link in the description below from where this formula sheet can be downloaded. A closer look. This is the top part of that same formula sheet. As I said, you do not need to memorize these formulae, as this formula sheet will be provided during the math examination for CSEC. And this is the below part of that same formula sheet. While you do not need to memorize these formulae, you do need to know when and how to use them. So as I said, we are at section 7, Relations, Functions, and Graphs. We have completed all objectives on this page and on the next one and on the next one up to objective 13 and up to objective 17. All of those have been completed. Up to objective 20 from this page, all of those have been completed. Up to objective 22 from this page, all of these have been completed. So right now we are at the last page. We have to go up to objective 26. We are now at 23. So we are here, objective 7, section 7, objective 23. As I said, we have completed up to objective 22. And up to that point, some of these videos have been published in their entirety on YouTube. these indicated in yellow here, including this one, and the others are only partially published on YouTube. By now, you know that if you need access to these that are only partially published on YouTube, you could check the description below in this video how to get access to those. I am right now at video 23 down here. When this is finished, it will be published in its entirety. And this is just an overview of how the videos from this section have been or will be published for those remaining videos. So as I said, we are here, objective 23 in section 7. And it says specifically that you need to sketch the graph of a quadratic function expressed in this square format and determine the number of roots. Now it just says sketch, not actually draw, just sketch. In the last video, we have seen graphs of 7 examples of this type of vertex form of the quadratic equation. Though those graphs were not really required there. The graphs were not required, but we have seen the graphs. Note that in this objective, you are not required to actually draw the graphs, but just to sketch them. So first, we will review the salient points that can be deduced from the vertex formula format, which is this. And then we will sketch the graphs and determine the number of roots, which you could do before you sketch the graph, but more so in order to sketch the graph, because not only do you need to know the number of roots, you need to know what the exact roots are. So example 1. First of all, we will review the salient points that can be deduced from this vertex formula format. So let's look at this equation here. If we were to plot that on a graph or sketch it, what do we know? We know that the y value of the vertex is k, which is 8. We know that. Remember, we need to get some data points to plot the graph. We also know that the x value is negative h, which in this case is negative plus 1, which is negative 1, negative h. So we know what the vertex is. That is the turning point. The vertex is negative 1, 8. That's what we can deduce from that, which we did in the last video. Now, we also need to know if this is a maximum or a minimum point. Now, if a is greater than 0, the vertex is minimum. If a is less than 0, the vertex is maximum. In this case, since a is less than 0, it is actually negative 2. The vertex is maximum. This point will be the highest point that the graph will go. So we have all of those. We now need to know one more thing, the x-intercepts, which will actually be the roots. So if we let y equal to 0, we have the rest of the equation there. We solve that. We eventually ended up with x is equal to negative 3 and positive 1. So we know it has 2 roots, and the 2 roots, that is where it cuts the x-axis, will be negative 3 and positive 1. At this point, we have all the information we need to sketch, remember, sketch the graph. And we not only know the number of roots, we even know what they are. So 2 roots, and they are negative 3 and 1. So this is the information we have. We could have found the number of roots before we calculated what they were over here. We could have done that if all we needed was the number of roots. looking at that equation alone. And this is how it's done. To find the number of roots from the vertex form, check the signs of A and K. Now you would have two roots if A and K have opposite signs. If A and K have opposite signs, you will have two roots, as in this case. You would have one root if K is equal to 0, if you had nothing here. And you would have no real roots if A and K have the same sign. Now, in this case, we have two roots since A is -2 and K is +8. Opposite signs, so two roots. And we know what they are. We already calculated them because we needed to sketch the graph. So these are the pieces of data that we have. So you get two axes. You may need to make some adjustment of how far you carry each of these axes based on the data you have here. What do we know about this? Well, we know that the vertex here is, so that's the vertex. Well, we also know that the axis of symmetry is x is equal to -1 based on this and based on -h. The axis of symmetry is -1. We also know that that point is a maximum point. The graph will go up to there as the highest point. So the rest of the graph will actually be down below here. We know two roots. The x-intercept, one is -3 and one is 1. So one is here and the other one is over here. At this point, you could probably imagine a graph going up like that, turning there, and coming down here. You could probably imagine that. But we have to sketch it. Now we will sketch it. This is what the sketch of the graph looks like. You probably don't need all of that. Maybe just this piece that you see here in the green box. We have the vertex, -1, 8, the highest point. It is maximum. We have the axis of symmetry. We know that point is maximum. We know the roots are here and here. So we know the x-intercept, -3, which is this one down here, and 1, which is this one here. So this is what the sketch of your graph will look like. That is what the sketch of your graph will look like. If you want, you could put in these after or even before. Now, as I said, the two roots, if A and K have opposite signs, one root if K is equal to 0, and no real roots if A and K have the same sign. In this case, we have two roots since A is -2 and K is +8. So we have two roots. If you find this video useful and interesting, please like and share. That is to say, like and share. You may also consider subscribing to this channel. Now, example 2. So again, we will review the salient points that can be deduced from the vertex formula format, which is this format. This is the equation we have. Y is equal to open bracket x plus 3 close bracket squared minus 9. Now remember, there is a +1 in the front here. We may tend to forget that. So A is +1, H is +3, and K is -9. The vertex Y value from that expression is K, which in this case is -9. and the vortex x value is negative h, which in this case is negative positive 3. That's a positive 3 there, which would give us negative 3. So the turning point, the vertex, is negative h, k, which is negative 3, 9. Negative h, k. So that becomes negative 3, negative 9. So the turning point is negative 3, negative 9. Now, if a is greater than 0, the vertex is minimum. If a is less than 0, the vertex is maximum. In this case, a is greater than 0. It is actually 1. And that is why I was telling you not to forget that there is a 1 there. So the vertex is minimum. The graph opens upwards. This would be the lowest point. We now need to know one more thing, the x-intercepts. That is where y is equal to 0. We need to know them in order to sketch the graph. So we set y as 0. And since it is in this format, it is fairly easy to solve. You find the square root of both sides. And so you get x plus 3 is equal to plus or minus the square root of 9, which gives us plus or minus 3. And we work that out and we get that the x-intercepts are negative 6 and 0. So right now we know that there are two intercepts and we know what they are. At this point, we have all the information we need to sketch the graph. And we not only know the number of roots, we also know what they are. Negative 6, 0. We could have found the number of roots before we calculated what they are, if that is all we wanted, just the number of roots. But you see, we need to know what the roots are in order to sketch the graph. But if all you wanted was to find out how many roots that equation has, looking at this vertex format, you would check the signs of a and k. It would have two roots if a and k have opposite signs, one root if k is equal to 0, and no real roots if a and k have the same sign. In this case, we have two roots as a is positive 1. Remember, there is a positive 1 there. And k is negative 9. They are opposite signs, so we have two roots. As I said, we even know what the two roots are at this point. So now let's sketch the graph. Again, you may have to adjust these axes based on this data you have here. We know that the vertex is down here. Negative 3, negative 9. Negative 3, negative 9. That's the vertex. We know that. We know that this vertex is a minimum, so that would be the lowest point. We also know the axis of symmetry, which is x is equal to negative 3. So that is the axis of symmetry. This point here is minimum. We know the x-intercepts, which is negative 6, 0. Negative 6, which is here, and 0, which is here. Can you imagine a graph coming down here, past that point, come down here, turn at that point there, turn up here, and it goes up like that. Now let's sketch a graph, which would look something like this. Let's double check that that graph meets all the requirements that we had over here. We know the vertex is down here. Negative 3, negative 9. We know the axis of symmetry is negative 3. We know that this will be a minimum point. We also know the two x-intercepts are -6 and 0. So you have been able to sketch the graph like that. As I said, it has two roots. We already know what those are, -6 and 0. How do we know it has two roots? Because A and K have opposite signs. So this is the sketch of your graph. You could include those annotations, or you could leave them out and produce this. But if you put in the annotations, it would be easier for anybody marking this question for you. If you put in these, example 3. Again, we will review the salient points and then we will sketch the graph. So what do we know from this vertex formula format? What can we deduce from that? Based on the last video, and now that we are basically reviewing that again, this is our equation. Remember, this is A, which is -6. This is H, which is -1. And this is K, which is 0. We don't have anything there. We don't have anything there. Okay, keep that in mind. The vertex Y value from that expression is K. That is, in this case, it is 0. We don't have any expression there. So K is equal to 0. The X vertex value is -H, and we do have that. H is -1. If we take the negative of that -1, we get +1. So now we know the turning point, or we know the vertex is -HK, which is 1, 0. Now, is that point a minimum point, or is it a maximum point? If A is greater than 0, the vertex is minimum. If A is less than 0, the vertex is maximum. Now, in our case here, A is less than 0. It is actually -6. So that vertex is maximum. It will be the highest point that the graph will reach. We now need to know one more thing. The x-intercepts, that is where y is equal to 0. And as I said, because of the way this equation is organized, with that square there, well, we know it would have one root because k is 0. So this is y is 0 at the turning point. If you square both sides, well, you can square 0. And so you end up with x is equal to 1. So it has one root, and it is at 1 on the x-axis, meaning it will just touch the x-axis at 1, 0. At this point, unlike the previous two examples with two x-intercepts, we do not have all the information we need to sketch the graph, since we only know one point, which is the root, which is 1, 0. We also know that it is the maximum point, but then how do we sketch that graph? So this is what we have. That is all that we have. We know the graph will come up to here, maximum. It will come from somewhere down here, go up to there, and come down back. But that is not enough to sketch the graph. We need some more points, maybe 1 or 2 points on this side here of that axis of symmetry, and another 1 or 2 points on this side here. So just how do you sketch a graph with only one known point, 1, 0, even if you know that it is the maximum point? We need at least 3 points, one on either side of that vertex, at least 3. So we set up a table this is a point that we know, we use the equation to calculate one or two other points on the left of the axis of symmetry, which would be these, and then one or two other points on the right of that axis of symmetry, and that would be these. Now, with those 5 points, or even 3, one from here, that vertex, and one from down here, anyone, we now have enough information to plot the graph, which will look like this. You don't need to plot this graph as big as that. All you need is this part here in green. We have the vertex, which is 1, 0. We have the axis of symmetry, which is x is equal to 1. We know the x-intercept is 1. We know it is a maximum point. And then we needed 1 or 2 points on the left here, 1 or 2. 2 would be better. And then 1 or 2 on the right here to sketch the graph. So with the annotation, that is what your graph would look like. Without the annotation, this is what it will look like. Example 4. Again, we follow the same steps. We review the salient points from the vertex formula format, which is this, and this is our equation in that format. Reminding you again that that is A, which is positive 2. This is H, which is positive 1. And that is K, which is positive 5. Okay. So the vertex Y value from that expression is K. In this case, it is positive 5. The vertex X value is negative H, which in this case is negative of positive 1, which would give us negative 1. So the turning point or the vertex is negative HK, and in this case is negative 1, 5. Let's determine if that is a maximum or a minimum turning point. If A is greater than 0, the vertex is minimum, is the lowest point that the graph will go. If A is less than 0, the vertex is maximum, is the highest point that the graph will go. In this case, A is greater than 0. It is actually 2, as we see here. So the vertex is minimum. The graph will open upwards. This will be the lowest point that the graph will reach. We now need to know if it has any x-intercept, that is at y is equal to 0, and if so, what are they? Before you do that, you can also note that this function has no roots, since A is positive and K is also positive. When A and K have the same sign, the graph does not touch the x-axis. It doesn't cross the x-axis, it doesn't even touch it. So it has no root. So we can go ahead and solve that. But what is the square root of negative 2.5? So it has no root. So at this point, we have insufficient information or data points to sketch the graph, since we only know the vertex and that the vertex is minimum. That's all we know. We do need to know at least 1 or 2 more points on the left of that axis of symmetry and 1 or 2 more points on the right of the axis of symmetry. So if you have this, what do we know? We know the vertex is here, negative 1, 5, that is the vertex. It's a minimum point, so that graph is going to come from somewhere up there, come here, and go up that way. But we don't have enough data to even sketch the graph. We know the axis of symmetry, x is equal to -1. Still don't have enough data points to sketch the graph. Okay, we know that. We know it's minimum. Yes, but can we sketch the graph? So just how do you sketch a graph with only one known point, -1, 5, even if you know that that is the minimum point? We need some more data points. We need at least 3 points, one on either side of that vertex. One on the left-hand side here, and one on the right-hand side here of that axis of symmetry. At least one on either side. 2 will even be better. So what do? This is the point we know, -1, 5. We choose another point or 2 on the x-axis to the left, and we calculate the y values, and then we do the same thing to the right, calculate the y values. As I said, we will need one or both of these here, and then one or both of these here. So now we have at least 3. Let us say we have 5 coordinates of points, including the vertex. And this is what your graph will look like. Remember, we know the vertex. We know that it is a minimum point. We know the axis of symmetry. And then we needed 1 or 2 more points here, so we could sketch a reasonable looking graph, which would look something like this. Example 5. Again, we follow the same steps. We have this vertex formula format, is this, completing the square format. This is the equation we have. I am emphasizing that in front here is a, and in this case it is -1. This here is h. So when I say h, this is what I mean, -4. And this here is k. So when I say k, as it relates to this equation, I mean -5. All right, so the vertex y value from that expression is k, as is, and in this case it is -5. K, -5. The vertex x value is -h, which in this case is -4. So remember, this is h. The negative of that will give us +4. So the turning point, the vertex, is -hk, which in this case is 4, -5. Now, is that a minimum or a maximum turning point? If a is greater than 0, the vertex is minimum, is the lowest that the graph will go. If a is less than 0, the vertex is maximum, is the highest the graph will go. In this case, a is less than 0. It is -1. Let me make sure you understand that. A is less than 0. It is -1. There is a -1 here for A. Therefore, it will be a maximum turning point. That will be the highest point that the graph will go. We now need to know if it has any y-intercepts, and if so, what are they? As you could see, A has a negative sign. K also has a negative sign, same sign. Therefore, this function, therefore this equation does not cross nor even touch the x-axis. You can go ahead and calculate it, but what is the square root of -5? There is no square root for -5, so it has no roots. At this point, we have insufficient information, data points, to sketch the graph, since we only know the vertex and that it is maximum. That's all we know. So we know this. Let's calculate 1 or 2 points on the left of that 4 for the x-axis, and we get these coordinates here. We get those, and let's calculate 1 or 2 points on the right. So as I said, we will need one or both of these on the left of that 4. Remember, 4 is on the x-axis. And we will need one or both points here on the right of that 4. Now, in this case, we are just using the 4th quadrant. We don't have need for the rest of the quadrant, the rest of the what you would normally see when you draw the 2 axes, based on the data we have. So we know the vertex is here, 4, -5. We know that. We know its maximum. Well, we know its maximum. So that's the highest point it will reach. We also know the axis of symmetry. Well, if we didn't have those extra points, it would be difficult for us to plot this graph. But now that we went ahead and calculated 2 points on this side and 2 points on that side, we can plot the graph, which will look like this. Our vertex is here, 4, -5. That's maximum, the highest point it will reach. This is the axis of symmetry, which is at 4 on the x-axis coming down. It has no root, as it doesn't cut the x-axis nor even touch it. And so for this, with the 1 point only that we have, the vertex, we had to get at least 1 or 2 more points on the left of that axis of symmetry, calculated, and then at least 1 or 2 more points on the right of that axis of symmetry. So that will be our sketch of this equation, given in that format. To conclude, let's review what we have learned. So far, we are aware of 3 quadratic equation formats. 3. The first one, this one that you are more familiar with, is the standard format. Y is equal to ax squared plus bx plus c. Okay. The next one is the factored format, so that y is equal to x plus a multiplied by x plus b. You factorize it. And the third one is this one that we have been looking at in the last video and in this video, which is called the vertex format. And maybe it's called a vertex because you could easily find the vertex from that and that. It's -h and k. You could look at it and see the vertex. You could even know whether that vertex, whether that graph opens upwards, so it's minimum, or opens downwards, maximum. You could even know the axis of symmetry from that h, but it has to be -h. So that is the standard format, this is the factored format, and this is the vertex format. 3 ways of expressing the same equation. This last one here is a times x plus h squared plus k. Now it's very difficult to get that standard format into this vertex format. But if you are given the vertex format, it's fairly easy to sketch the graph and to get all the information we were talking about just now. The vertex y value is -4 from this. You could see it there. Look at those other 2 equations. You don't see a -4. The x value is -h, which is -3. You could basically see it here. Change that h to negative. You know the turning point is negative hk, you could see it clearly out of this vertex format. You change that into negative, and this is h, and that is k. The axis of symmetry is negative h if you are given in this format. We also know that if a is greater than 0, the vertex is minimum, and if a is less than 0, the vertex is maximum. So in this particular case that we are looking at here, a is 1, so the vertex is minimum. That's the lowest point that the graph will go to. This is the lowest point. The vertex is minimum. We know we can find the roots of this vertex format by just looking at it. If a and k have opposite signs, you have two roots. If k is equal to 0, you have only one root, and you don't have any real roots if a and k have the same sign. So in this case, a has a positive 1, a has a positive 1, and k has a negative 4. Opposite signs, we have two roots. In the event that there is one or no root, you will need to calculate at least 1 point, or better 2 points, on either side of the vertex, that is to say, of the axis of symmetry, in order to sketch the graph. So this was objective 23 in section 7. Sketch the graph of a quadratic function expressed in this form and determine the number of roots. You can determine the number of roots without sketching the graph. But if you want to sketch the graph, you need to know how many roots you will have and what the roots are. And that brings us to the end of video 23 based on objective 23 in this section.